Iris Tool 11 consists of TSO-DSO planning suites. In today's rapidly evolving energy landscape, several key challenges have emerged that demand attention and strategic action. Firstly, there is an increasing demand for a reliable energy supply. As our reliance on electricity grows, ensuring that we can meet this demand consistently is critical. Compounding this challenge is the increasing risk of circuit failures, which can be exacerbated by cyber attacks and extreme weather conditions. With the frequency of such threats on the rise, safeguarding our infrastructure is a priority to prevent disruptions that can have widespread repercussions. At the same time, there are significant opportunities to leverage local energy storage, distributed energy resources, and demand flexibility. By harnessing these assets, we can enhance the supply resilience. To navigate these challenges effectively, it is essential to optimize the portfolio of local resources and network design. By thoughtfully integrating and unpacking these elements, by using Iris tools, we can build a robust and resilient energy framework. The tool uses an Excel spreadsheet as the interface to collect the input data and to store the results. The input data include network data, load profile, distributed generation and storage, level of demand flexibility, cost of new devices, a set of credible contingencies, and the target KPIs. Those data will be processed by some algorithms involving optimal power flow and the distribution planning algorithms to identify the new investment needed, their capacities, and location. A VPP algorithm is used to represent the distribution resources to the transmission system operator, and the transmission reliability tool will analyze the impact of different network redundancy levels on the customer's reliability. By putting different input assumptions and network design options, sensitivity analysis can be performed to provide a deeper insight. Finally, the operator fabric is used as a communication channel between the user and the developer of this tool. The Control tab of the tool provides a summary of the test system and several buttons that activate the macro to execute certain functionalities. In this file, the users can provide input data of the distribution system such as the network, the load, and the generation data to the relevant tabs with light blue background, while the results such as voltages, flows, active and reactive power outputs are stored in the tabs with light yellow background. Here is one of the distribution test systems in R²D². The system is already well designed with several alternative entry points to improve reliability. Furthermore, there are some solar PV generation mainly connected to the east part of the system. Large demand customers are primarily connected to the west part. The tool can then be used to identify scenarios which will result in the loss of supply for specific customers as shown in the bottom right table. Double circuit faults, as shown in scenario 3, lead to the highest loss of load, especially industrial loads. To increase the resilience, the tool proposed the deployment of 3.78 MW static generators and 2 times 0.95 MW mobile generators which are located near or at the industrial loads. Visualization of the modeling results are enabled by presenting the network state variables such as voltages, flows, circuit loading, and the aligning checks on the graph like shown in this slide. The final part of the tool is the transmission reliability studies. The objective is to facilitate a comprehensive impact assessment of different network designs or redundancy levels on the supply reliability, considering the resources at the distribution grid. A set of cases can be set up considering different peak demand, the number of circuits connecting transmission to distribution, ratings, failure rates, and parameters for distributed generation and demand-side response. The tool will calculate the expected energy not supplied and the corresponding value of loss load. Two graphs on the right show the value of loss load as a function of peak demand and the number of transmission circuits. This will help the system planners to determine which design can be used to meet the resilience target. Thank you for listening.